with new material. So after this, it just is basically going back and remembering stuff and learning little tricks. Okay, so this is the last of the new stuff. Okay, and it's not even really that new because it's just the undo of what we learned on the last section. Okay, so last section we learned that the derivative of arc sine was this. Okay, and we learned the arc cosine. Remember that? Even though they didn't write it down, so remember the arc cosine. What was the difference between the arc cosine and the arc sine? Uh-oh. I'll give you a hint. It has a lot to do with the same as like the derivative of just sine and cosines. Just negative, exactly. So the arc cosine derivative is a negative u derivative over 1 minus the square root, or the square root of 1 minus u squared. So just remember that. Okay, and then arctan basically is a plus sign on the bottom and you take away the square root. Okay, so notice the difference between those two. The bottom is where you can tell. Okay, so arctangent, there's no square root. Arc sine has a square root and it's a minus. Okay, so this right here is your integral piece. So this is what we're going to be working with today, these two. Undoing it. So we're adding a plus c. Okay, and then these are the two, they're going to make it a little bit more awesome. Okay, so instead of just having ones, notice that they throw in an a squared. Okay, so if you look at the difference between the definition above and the definition below, if there's an a, so if the number is other than 1 on the bottom, you're going to divide by it. Okay, if it's arc sine, it just goes after the sign. If it's arctangent, it goes front and after. Okay. So, are you ready for this? I'll take that as a woo, yeah. Okay, so warming up, we're just differentiating. Okay, so finding the derivative. So we're using this very top one, top left, that one. Okay, if I have the arc sine of x over 2, what do I have? What's the derivative of the u? So first of all, what's the u in this scenario? What's that? So it's the piece after the arc sine. One with the x though. So we can say 1/2 x, right? So x over 2 is the same as 1/2 x. Okay, so by definition, we're going to do the u derivative over the square root of 1 minus the u squared. Okay, so we're filling in that piece. Okay, so what is the derivative of 1/2 x? 1/2. Okay, then divided by. So on the bottom, I'm going to have 1 minus, and then I'm going to square it. So it's just going to be, I'm going to write this as x over 2 because I want it to be written the way it was originally written. And I'm going to square it. Okay, so if you rewrite that, since you have a 1/2 in the top, the 2 can go down into the bottom. Okay, and then since I have the fraction squared, I'm just going to square the top, square the bottom, so I get, what, x squared over 4. So that would be simplified. Okay, not too bad there. Turning things on a little bit. Nothing. Not going to write it down at all. Oh. Okay, so now we're integrating. Okay, so the first thing we're going to figure out is it an arc sine or is it an arctangent? And then we're going to figure out what the u is and if there is an a. Okay, so is this an arc sine or arc tangent scenario? Arc sine, right? Because we got a square root, subtracting. Okay, so first of all, let's identify what the a value is. Okay, so notice in the definition, Okay, my a value is squared. Okay, so if I have 4, what is my a value? 2. Good. Everybody see how that you have to like square root it to get to the a value? Okay, then what's your u value? Ditto on that scenario. Okay, so just x, right? Okay, so then I'm going to go ahead and just derive that so we can just fill in our definition. So what's the derivative of x? 1. Okay, so now I can just go ahead and write this definition. See that number 1 at the top there? Okay, so it's just going to be the arc sine of the u over a. So my u is x, my a is 2, and plus c. Okay, so no, because by the definition, it's a squared minus u squared.
Yeah, but if you're squaring the square root of x squared, wouldn't it just take out the square root?
No, not if there's a minus underneath. Okay, number 2. So is number 2 a arc sine or is it a arc tangent? Arc tangent. Okay, so you see the difference between the two? Now we don't have a square root. There's adding. Okay, so I'm going to figure out what my pieces are. What's my a? Remember that comes from the constant. So I'm looking at 25. So what's my a value? 5. Okay, now my u value, what number has been squared to make 4x squared? 2x, good. Everybody follow that one? 2x. Okay, so then I'm going to derive that just for helpfulness. Oops. So what's the derivative of 2x? 2. Okay, so now I'm looking at that definition number 2. So it's going to be 1 over the a. So I have 1 over 5 arc tangent of my u, so 2x over my a, which is 5, plus c. Oh, I screwed that up. It's a good thing I looked back. I screwed this up. Anybody see how I screwed this up? Look at the top. It comes from the top how I screwed it up. So the top is the u derivative. So is my top my u derivative? No. So what do I have to multiply by? 2. So I have a 2 out front, which means to undo it, what do I have to divide by? Divide by 2 or multiply by a half. Yeah, so I need a 1/2 in front of that. So, yep. 1/10. Okay, so everybody okay with my mistake and that makes sense? Don't do that yourselves. Okay, let's try number 3. Let's see if this kind of works out the same. So for number 3, are we doing arc tangent or arc sine? So arc tan. Okay, so what's my a? This is a little tricky because it's a 3. So what number has been squared to become 3? Good, yeah, the square root of 3. Perfect. Okay, so then my u is what number has been squared to make 4x squared? 2x, right? That makes sense, because 2 squared is 4. Okay, so then u derivative is 2. Okay, so now this time when I look at this, I'm going to do this right away so I don't screw it up again. I'm looking at the top and comparing it. So is 2 the same as 8? No. So how do I make the 8 turn into a 2? Close. Divide by 4. Yeah, because I have to make it smaller, right? Okay, so what I'm going to do is I'm going to say 1/4 here, because that will turn the top into a 2. And then on the outside, I have to undo the dividing by 4, so I'm going to multiply by 4 on the outside of the integral. Does that one make sense? Okay. So now I can go ahead and do this. So I have 4. Okay, so I have, by the definition of arctangent, 1 over a, so the square root of 3, arc tan, and it's u over a, so 2x over the square root of 3 plus c. So you could, and this is, in my opinion, I don't know, kind of unclear. The textbook leaves this as 4 over the square root of 3, arctan, and 2x over the square root of 3 again, like this. So I think that that's fair game to leave it if the textbook is doing this, but just be aware that that's technically simplifiable, right? You can't really leave a square root in the bottom. So just realize on a multiple choice question, they might simplify that. Okay, on a free response, you can leave it. So we'll just leave it for now and just make sure that we know. Okay, number 4. Okay, so first of all, what rule is this one? So is this an arc? Is this an arctangent? What do you notice is kind of different? The nice thing is that they put these side by side, 3 and 4. We just used arctangent on number 3. So is number 4 an arctangent? With the x up there? No, it's not. Okay, and it's because it has a variable on the top. Okay, arctangent can only have a constant value in the top. So we have to use a different rule. Okay, so this is kind of going back, and now you're thinking, okay, well, I can use my sheet here, if you guys have them, on the integral sheets. Okay, so remember, or even the one that I gave you is probably more helpful with integrals, I think. Okay, which rule do you think we might try to use? This rule comes back a lot. Talked about it in the last section. Yeah, it's the rule number 14. Okay, so anytime you can't use your arc tangent or arc sine. Okay, so you guys remember rule number 14? So rule 14 looks like this. The derivative over the u dx is equal to the natural log. Whoops, I did not write that correctly. The natural log of the u plus c. Okay, so anytime you see, for me, that's kind of my go-to. I would start by looking at that, unless it was blatantly obvious. I mean, if there was a square root in the bottom, I would probably think arc sine, but I would start with a rule 14. So if we think about this, what's the derivative of the top? Or excuse me, what is the derivative of the bottom? 8x. So that one is literally a rule 14. I don't have to adjust it in any way, right? Because it's 8x, exactly the same. So what is the integral of this? What's my answer? Good. Natural log 3 plus 4x squared plus c. Okay, so that one is a literal, and they throw that in there because you have to be aware of, you can't always use arc tangent or arc sine. It's not always just that simple. This section is not just arc sine and arc tangent. They're going to throw in your other rules so that you have to practice them and see the difference. That is the hardest part of this. A 6x? Yeah, so 6x, if it was a 6x, you would have to say, okay, well, what would I have to multiply 8 by to make it 6x? And then you'd have to undo it. So 6x would be pretty nasty, but it would work. Right, because it's exactly the derivative of the bottom. But if it wasn't, we could manipulate it if it was just like a constant difference. But if it was like, let's say the bottom was like 4x cubed on the bottom, and so your top was 12x squared, and if you looked at those, you can't turn an x into an x squared. So you couldn't use rule number 14 in that scenario. You'd have to do something different than that. Okay. Oh, bam, look at that. They're like reading our minds. Okay. So, if it is this scenario where you have an x squared and you can't manipulate the top so that it becomes the derivative of the bottom, what other methods do we know when there's fractions involved? Does anybody remember this one? You try U-Substitution. That's a good idea. Which one would be your U? Yeah, usually it is the bottom piece, the piece that has the exponent, but they're the same exponent. So U-Substitution is not going to work either. So when nothing works, you use long division and you break it down. So the idea is that you rewrite it. Okay, so this one is a long division problem. These ones I think are the hardest ones to see. Okay, so you would do, I'm going to write this in the correct order, 4x squared plus 3, and then the 8x goes in the box. Okay, so you start by looking at 4x squared and comparing it to 8x squared. So what would you multiply 4x squared by to make it 8x squared? 2. So the 2 goes on the top, so you multiply that through. So 2 times 4x squared is 8x squared, and 2 times 3 is 6. So you subtract. So what's my constant? Good, -6. So this becomes, I'm going to say, minus 6 over the divisor piece. Oh, I keep writing a 2 instead of a 3. Let me erase that. Okay, so on my rewrite here, this is equivalent to integral of 2, and I would separate this out, dx, minus the integral of 6 over 4x squared plus 3. So separate it as 2 different integrals. I mean, you don't have to write that notation out, but I think that when I do it, it makes more sense in my brain. Okay, so what's the integral of 2? 2x. Okay, what about this next piece? So now I have another fraction going on. What are you guys thinking for that? I got a constant on the top. That should help you notice something. So it's this is an arctangent scenario. Okay, so I'm going to use a blue for just this piece now. Sorry, I'm kind of switching over in there. Okay, so my A, so I'm looking at the 3. What's my A? Square root of 3. What's my U if I'm looking at 4x squared? X. What's my derivative of U? 2. Okay, so if I look at the top, the 6, are they exactly the same? No. So how do I turn 6 into 2? Divide by 3. So I have to divide by 3, and to undo that, I have to multiply by 3. So this is going to turn into, let me write this minus over more so I have more space, minus 3. So we're looking at an arctangent, right? So arctangent is 1 over A, so 1 over the square root of 3, arctan of the U over the A, 2x over the square root of 3, plus c. Oh, that's really all squished together. So let me rewrite this so it looks a little better. It would be 2x minus 3 over the square root of 3 arctan of 2x over the square root of 3 plus c. So that one's not too bad. Are you ready for number 6? Okay, so what do you think about number 6? So first of all, when I see a square root, I say, okay, is it arc sine? Can it be an arc sine? Why not? Exactly. Very good. As long as it's not a constant, I cannot use an arc. Okay, so it's not an arc sine. Okay, so my next idea is it a rule number 14? Is the bottom, or excuse me, is the top the derivative of the bottom? And immediately I say that there's a square root involved with a quantity. So can it be a rule 14? No, it's definitely not a rule 14 because I have that quantity in the bottom. So I'm thinking U-substitution is probably my best option. Okay, so if I think U-substitution, I'm going to write this down just so you can see it. My U would be the piece that's inside the square root, right? 4 minus x squared. Don't write this down. I'm just giving you a hint. Okay, so I would derive this. So what's the derivative of that? Negative 2x dx. Okay, so my next step on a U-substitution is I'm looking at the stuff that's on the outside. Can I replace it? Is x plus 4 exactly the same as negative 2x? Are they equivalent at by any means? Can I multiply or divide by something to make them the same? Some constant number? No. Okay, so this is a scenario where U-substitution does not work. So there's one, it does work. There is something that does work. Okay, so this is the last scenario is your rewrite. Okay, so anytime you have a fraction and you have adding on the top, remember that you can separate it into two different fractions. Okay, so it's kind of like, you guys know, like this would be hard for you to see, but you know that if I have x plus 4 over, let's just make it easy, 3, that's equivalent to x over 3 plus 4 over 3, right? Okay, so that's what we're going to do with this question is we're going to separate it into two different integrals and hope that that helps us do something. Okay, so if I rewrite this, this is going to be x over the square root of 4 minus x squared dx plus the integral of 4 over the square root of 4 minus x squared. Okay, so now we're going to do these individually. Okay, so the first one, can I use an arc sine on the first one? No, why not? Variable. Okay, so since it's an x, funny, you guys are funny. Since it's an x, I can't do an arc sine, so what do I do next? What's my next option?
Yeah, sorry about that. I forgot to put the bells back to the regular schedule.
It's like Mondays are always.
Now the top you can use the negative 2x.
Yeah. Yep, you got it. So my u is 4 minus x squared. My du is negative 2x. So this one I can rewrite. So if I just multiply by negative 2, I can undo it. Yep. So this one is a U-substitution, right? You guys see why it's a U-substitution? Because you have to do because the bottom is inside a square root, which, by the way, the square root is the same as what? Exponent to the 1/2. Can I go ahead and pull that all up in one step and just say I have negative 1/2 u to the negative 1/2 here, du. Okay, and I'm just going to keep going with this and deal with the other integral later. So what's the integral of u to the negative 1/2? Yep, u to the 1/2, and then since you divide by 1/2, that's the same as by 2. So for this one, the 2's cancel, so you're left with a negative u to the 1/2. I'm going to fill in my u right here. And I'm going to write this as a square root, since it started with a square root. Okay, so there's that one. Okay, so now let's do the right-hand integral. Can I use an arc sine on that one? Yes. This one I can use an arc sine on. Okay, so arc sine, let's figure out what the a is first. So I'm looking at the 4. So what number was squared to make 4? 2. I need to figure out what my u is. So what number was squared to make x squared? X. What's the derivative of x? 1. So if I compare 1 to 4, are they the same? No. How do I make 4 turn into 1? Divide by 4. So I'm going to divide by 4, which means I need to undo it. Multiply by 4. So here comes my integration. I have a 4 out front. And we're doing arc sine. So arc sine just starts with an arc sine. And it's u over a. So x over 2. And we have a plus c out front. So I'll just drop this down to the other one. So plus 4 arc sine of x over 2. Okay, is that it? That's it. So, I'm going to give you guys 1 through 22 for problems. Okay, and these ones I highly suggest that you guys go through and do. Okay, there needs to be work on your